All right, let's continue on. I've just went back over to the description of our exercises for this week because I wanted to check in and see how far along we are. So we've calculated the trend yields. We've done number 1. We've calculated each year's percent deviation from trend yield. We've got the plot of yield per harvested acre against good plus excellent. Oh, we've done the yield per harvested acre across years. So now we're ready to start in on number 3. So we're going to go over there and plot yield per harvested acre against what is in the good plus excellent category. And as we do that, we're going to think about what problems arise if we try to use the yield as an independent variable instead of those percent deviations. So let's talk about that. All right, so let's add yield per harvested acre against good plus excellent. So I've already added these two together and provided it in column H. You can see 84 is 55 plus 29. So I'm going to hold down on my control key, click this, hold down on the shift and arrow down. Now I can go to the insert chart menu, insert XY scatter, and yeah, I'll choose the dots in this case. The connected lines will be crazy and not very accurate. All right, let me make the size of the fonts a little bit bigger. Okay, so you could just go straight to trying to forecast yields from this, where you take my crop condition ratings and try to fit a trend line through here and forecast what yields are going to be based on this number, or based on some combination of these numbers. The problem with that is we see that yields are trending over time, and we talked a little bit in earlier sections about how when you're doing statistics, you need all of the data to be coming from a single distribution, and the mean of this data is clearly increasing over time. So if you tried to just fit a line through here, you would be messing up, because, for example, this 2012, which is a really, really bad year, you're going to get the same realizations as like a normal year from the 1990s. So that'll mess up your signal about whether this, let me go to 2012, about whether this reading of good plus excellent equals 25 is bad. It's messed up because, yeah, it's bad from the perspective of 2012, but if we had gotten 123 in 1990, we would have said trend year. So that's why that's not going to be that great for us, and we need to do something to remove that. Now you could just put a variable that captures the trend on the right hand side in the regression. That's another way to account for it and correct for that problem. But another way is to just use this percent deviation from trend, and then that kind of flattens everything out for us. So this is what it looks like. We're still seeing a positive relationship, but if we tried to fit a regression with yield as the thing on the left-hand side, the y variable, it would be messed up for that reason. So now let's do a chart that includes percent deviation from trend. So hold down Control and Shift and arrow down, hold down Control and then Control Shift, insert chart dots. Okay, now this looks even more promising. There's a pretty tight linear relationship, and this is figure 2 from the text that we saw in an earlier video. Okay. Alright, so by doing that, we have like 1988 realizations and 2012 here are pretty much on par with each other at minus 23%. And all of that trend effect is removed because of that. Before we move on and talk about the next thing, I noticed there was something here we didn't talk about yet. And that was this part of number 4. What problems will arise if we try to use the yield as independent variable we want to forecast and use these conditions? categories to predict it. And I said there's two big ones. We covered one, that was the trend. There's another thing that's much more subtle, which unless you've spent a little more time working in statistics, it may not occur to you that it could be a problem. But underlying these regression models is an assumption of normality. And one thing that you would know about a normal curve is that you're equally likely to get observations above the mean as below the mean. Whereas this physical phenomenon seems like we get more observations close to the mean or slightly above, but we're much less likely to get big deviations above than we are big deviations below. So we get above trend realizations more often, but we're very unlikely to get a plus 23%. We're very unlikely to get 23% above trend for a yield realization, whereas if it was a normal model, then we should have equally likely chance of getting a minus 23% as a plus 23%, which would land somewhere up here. Just given the physical, biological, chemical nature of growing corn, that's just not going to happen. So it's clearly not normal. Doing the percent deviation from trend yield doesn't fix that 100%, but it makes it a little less pronounced than what we have here. That kind of phenomenon is often modeled as log normal, so if we wanted to be even more careful about the fact that these things appear to be not normal, we could take the log ln of the percent deviations. We could do that. And then we'd have to adjust it because you can't take the log of a negative number, so you could do some transformation like log plus 100, and then try to fit based on that, but we'll just go with this. So it's something to be aware of if you pursue analytical stuff in the future, but this makes it, using the percent deviations already kind of flattens out this we call it fat-tailed situation. So we'll just go with that. Okay, so let me come back over here and see if we're ready for next. We plotted percent deviation against trend yield. And we talked about how the percent deviation does not suffer from the problem of the trending variable in yield. And it's a little bit less of a problem from the perspective of those negative yield realizations making the variable not normal. Okay, so next we just have two steps left. We're going to fit the regression model that has percent deviations on the left-hand side and those crop condition categories on the right-hand side. Once we do that, we're going to use that regression model to forecast yields through the growing season, but we'll save that for the next step. Now, before we get to fitting the regression model, I have to make note of one thing. I say here that we need to leave out one of the condition categories, and I need to talk about why, and it's going to get a little bit wonky, the reason why, so let me continue that in the next video.